A strange object, 3 Atlas, has entered our solar system. It was labelled a comet. Then something changed. It brightened. It turned blue. And now, in a discovery that defies all expectations, it's slowing down. This is not how comets behave. Not now. Not ever. And as of this week, one of the world's most prominent astrophysicists, Harvard's Dr. Avi Loeb, has gone public. On national television, he said 3 chilling words. It manoeuvred deliberately. This is no longer just an astronomical event. It's becoming a mystery of interstellar proportions. Multiple observatories, from Italy to Las Vegas, from NASA's JPL to virtual telescopes in the cloud, are tracking what might be the most controversial object since Oumuamua. But this time it's not just the motion, it's the jets, the strange colours, the silence from official agencies, and the December 19th encounter date that may change everything. In today's report, we take you inside the story, through telescopic footage, scientific testimony, and questions even Congress is now asking. What exactly is 3I Atlas? Why is it behaving this way? And what happens when it makes its closest approach to Earth just 6 days before Christmas? Let's break this down visually. Imagine opening a 3D star map using Skylive or Stellarium. Zoom in on the inner solar system. Between the Earth and the Sun, cutting through the plane of the planets, you'll see it, 3I Atlas. It entered quietly in September 2025. Astronomers noted its hyperbolic path, meaning it came from beyond the solar system, like 1I Oumuamua in 2017 and 2I Borisov in 2019. It was catalogued as the third known interstellar visitor, hence the name, 3I. But unlike the others, 3I Atlas did something that neither Oumuamua nor Borisov ever did. It changed its speed and direction. Most comets speed up as they approach the Sun due to gravity, then whip around and exit. That's orbital mechanics 101. But in late October, as 3I Atlas neared its perihelion, the closest point to the Sun, observatories detected an anomalous deceleration. Think about that, slowing down while falling into the Sun's gravity well. That's not just unexpected, it's physically impossible without some kind of internal propulsion. NASA's Jet Propulsion Laboratory, JPL, flagged the change. So did the Galileo Project team in Las Vegas. And then came the colour shift. Between November 6th and 9th, astronomers around the world reported a 5-fold brightening in 3I Atlas. But it wasn't just the brightness, it was the hue. Instead of glowing yellow-orange like most dust-laced comets, 3I Atlas shifted blue. Not just pale blue, bluer than the Sun itself. That matters. In astronomy, colour indicates temperature and composition. The Sun burns at roughly 1800 Kelvin. A bluer glow would typically suggest something hotter. And yet spectral data shows 3I Atlas isn't hotter than the Sun. So why is it emitting shorter wavelengths of light? No answer yet. But experts agree. Something about its surface, its jets, or its energy source is abnormal. Just a day later, November 7th, Dr. Avi Loeb appeared on Newsmax. He dropped a statement that stunned even seasoned space journalists. It manoeuvred. Loeb didn't say appeared to manoeuvre. He stated it directly. As fact. To understand why that's such a big deal, let's talk about who Avi Loeb is. Former chair of Harvard's astronomy department, founder of the Galileo Project, a research initiative designed specifically to detect and analyse non-human technology in space. He was one of the first mainstream scientists to call out the unexplained acceleration of Oumuamua. And now he's saying 3I Atlas may be doing even more. Let's go back to the star map. If you align the ecliptic plane, that flat, disc-like zone where the planets orbit, you'll see that 3I Atlas is almost perfectly aligned with Earth's orbital path. This in itself is extremely rare. Most interstellar objects cut across our solar system at wild angles. But 3I Atlas is travelling near coplanar, as if riding along with our planet. Now fast forward to December 19th, 2025. That's the date it will make its closest approach to Earth, a mere 6 days before Christmas. At that moment, it will be just over 6.1 million kilometres away, about 16 times the Earth-Moon distance. For astronomers, that's razor close by interstellar standards. And dozens of ground-based and orbital telescopes are preparing to capture high-resolution imagery of the event. But there's a catch. NASA already has a spacecraft that can image it. The Mars Reconnaissance Orbiter, MRO, equipped with the powerful HiRISE camera, has had an angle on 3I Atlas since October. But as of today, no images have been released. Why? NASA says they're analysing the data. But some scientists and even US representatives, including Anna Paulina Luna, are now pressing for full transparency. Congress has been briefed. Loeb has testified. And the longer the silence lasts, the louder the speculation grows. Meanwhile, the object itself is changing. Observations from the Virtual Telescope project in Italy, run by Dr. Gianluca Marsi, have shown an unusual core structure. Unlike most comets which emit symmetrical tails, 3I Atlas has no visible tail. Instead, it appears to have 7 jets. Shooting material out at strange angles. Think of it like a spinning garden sprinkler, but in space. And that material? It doesn't resemble traditional ice and dust. Spectral analysis from Las Vegas and Italy shows a nickel-rich composition. Low in iron, but anomalously metallic. In fact, the elemental profile resembles more of a fragmented asteroid, or something else entirely. All this brings us to the speed. Right now, 3I Atlas is travelling at approximately 150 kilometers per second. That's nearly 3 times faster than any rocket Earth has ever built, to generate the kind of acceleration and then deceleration that we've seen. Calculations suggest a mass ejection equivalent to 5 billion tons. That's a massive loss, about 10-20% of its estimated total mass, and yet there's no visible debris field, no scattered fragments, no spreading tail, just the object itself, intact, glowing, adjusting its trajectory. So what is 3I Atlas really doing? And who, or what, might be controlling it? Let's examine one more layer. Alignment. Right now, 3I Atlas is in the constellation Leo. That's east of the Sun, just past the ecliptic. But if you map out its trajectory, you'll notice something striking. Its approach path is within 9 degrees of the origin point for the famous WOW signal, detected in 1977. A still unexplained radio burst that lasted 72 seconds. Coincidence? Possibly. But in cosmic terms, 9 degrees is extraordinarily close, and it raises the question, could 3I Atlas be connected to past anomalies? In upcoming segments, we'll dive deeper into the congressional briefings, the Mars orbiter image delays, the possible December 19th fragmentation event, and the question no one wants to ask, what if this object is not entirely natural? We'll also compare it directly to Oumuamua and Borisov, exploring how 3I Atlas is rewriting the rulebook on interstellar objects. But before we continue, if you want to follow this story as it unfolds, especially when new data drops from NASA, Harvard, and international observatories, make sure you subscribe and turn on notifications. And tell us below, what do you think we're looking at? Will it break apart? Will it pass by silently? Or are we watching something designed to be seen? Leave your comment. I read them all, and the next few weeks may be historic. Imagine this. An object the size of a mountain enters our solar system at interstellar speeds. And then, instead of slingshotting past the Sun, it slows down. That's what we're now seeing with 3I Atlas, but the closer we look, the weirder it gets. Because the data pouring in from telescopes around the world doesn't just suggest anomaly, it suggests intent. Whether natural or artificial, the way this object moves and what it's doing now doesn't follow the rules of celestial mechanics. Let's zoom back out and focus on October 29th, 2025, the date 3I Atlas reached perihelion, its closest approach to the Sun. At that point, it was just 203 million kilometers from the solar furnace, closer than Mars but farther out than Earth. Typically, comets at this distance begin to sublimate violently. Gases burst from the surface. Tails form. Dust scatters. But 3I Atlas didn't develop a tail. Instead, it formed 7 discrete jets, arranged asymmetrically. What's more, the object showed a colour shift toward deep blue, even though its overall temperature was lower than Hamonai, the Sun's 800 Kelvin. How does something get cooler but emit bluer light? Astronomers at the Virtual Telescope project in Italy, led by Dr. Gianluca Marsi, are still trying to solve that question. Let's pause here Because this isn't just about visuals, it's about motion. Using data from NASA's JPL Horizon system, scientists plotted 3I Atlas's trajectory over a 90-day window. Everything looked normal. Until October 30th. That's when researchers at Harvard noticed a subtle change. A slight curvature, deviating just a few arc minutes from the expected path. To the untrained eye, that's nothing. But at interstellar velocities, 150 kilometers per second, even a small arc-minute shift indicates massive vector alteration. If gravity didn't do it, what did? Some scientists argue maybe it's gas jets, like a natural thruster. But calculations show the observed acceleration would require a mass loss of 5 billion tons ejected in a specific direction. And yet, there's no tail, no scattering debris, no coma cloud. Instead, the jets appear narrow and precise, more like controlled nozzles than natural plumes. This led Dr. Loeb to suggest, cautiously, that internal propulsion is not out of the question. Remember, comets don't brake. They either accelerate or follow a gravitational arc. Slowing down suggests an active force pushing against motion. At the same time, on the other side of the world, the Galileo Project Observatory in Las Vegas was capturing live images. Using adaptive optics, their system noticed a strange pattern in the object's emission. Every 11 hours, one of the jets would pulse, then dim, and another would ignite, rotating clockwise. Was this a thermal cycle, a chemical rotation, or something more coordinated? Galileo researchers logged this as a possible artificial pattern, though not conclusive. They noted that the energy distribution was unlike any known comet outgassing behavior. This observation was passed on to the Jet Propulsion Laboratory in Pasadena, but JPL declined to comment. Meanwhile, pressure was building in Washington. On November 5th, Representative Anna Paulina Luna introduced a public request to NASA's Science Mission Directorate, asking for the immediate release of high-resolution, high-rise imagery of 3I Atlas. Why does this matter? Because NASA's Mars Reconnaissance Orbiter, MRO, launched in 2005, is equipped with the high-rise camera, capable of capturing objects as small as 1 meter across from orbit. Given Mars's current position relative to 3I Atlas, MRO is one of the few spacecraft with a clean line of sight. But no images have been made public. Is this a delay in processing, or something deeper? On November 6th, Loeb submitted a report to the Harvard-Smithsonian Center for Astrophysics, analyzing the object's acceleration curve and projected deceleration slope. The conclusion: if this were a natural object, its motion violates both the standard gravity model and the expected solar outgassing profile. No known comet matches this behavior. The paper has not yet passed peer review, but it's being widely circulated among independent astronomers. Interestingly, some of them noticed a similarity between 3I Atlas and Oumuamua, the first interstellar object spotted in 2017. But there's a critical difference. Oumuamua didn't emit visible jets. It had no tail, no emissions, just a light curve and anomalous acceleration. 3 Atlas, on the other hand, is actively releasing material, but in ways we don't understand. This brings us to the upcoming climax. December 19, 2025, the object's closest approach to Earth. At just over 6 million kilometers, it will be observable with both optical and radar telescopes. NASA's Goldstone Solar System radar, ESA's Infrared Space Observatory, and amateur astronomers with high-end scopes will all be watching. Several things could happen. Natural fragmentation. The object splits due to internal stress. Metallic reflection. It reveals a solid, possibly artificial surface. Directional change. It maneuvers again. Silent pass. Nothing changes, and it exits without incident. But the wild card? If it releases smaller objects or emits a signal, the implications would be unprecedented. Let's go back to image analysis. So far, all imagery of 3I Atlas comes from Earth-based systems, Virtual Telescope Project, Italy. Las Vegas Galileo Array Harvard's CFA data relay. But several analysts, including teams at Caltech and SETI, have noted a problem. The object's brightness is increasing, but its surface reflection remains uneven. This suggests it's not a smooth sphere. It may be tumbling, or worse, modulating its surface deliberately. Speculation? Sure. But every time we update the models, they drift further from a standard comet profile. And remember, 3i Atlas isn't alone. In the last 12 months, telescopes have catalogued 6 interstellar candidates with similar traits: high-speed near-ecliptic entry, unusual spectral features, minimal, outgassing. The question now being asked in underground astronomy forums is, are we being visited systematically? If that sounds too far-fetched, consider this. The trajectory of 3i Atlas passes within a few degrees of the WOW signal's recorded source, and its light emissions match the wavelength used by some radar systems on Earth. Coincidence? Perhaps, but scientists love patterns, and this pattern is raising eyebrows. There's also the temporal coincidence. The approach date, December 19th, places the object directly between Earth and the Sun, just before the winter solstice. In ancient cultures, this period marked the longest night, a time of cosmic alignment and symbolic rebirth, purely symbolic, or more. It also aligns with the date range when Oumuamua passed closest to Earth in 2017, both in mid to late December. It's probably nothing. But it's strange. The next key date, March 16th, 2026, that's the theoretical intercept window calculated by Dr. Loeb. If a Juno-style flyby mission were to be redirected toward 3i Atlas. It's a long shot. NASA has made no comment, but Loeb insists the window is viable and has submitted preliminary designs through the Galileo project. He's also calling on private space companies, like SpaceX and Blue Origin, to consider fast launch intercepts. Even a flyby could answer the question, Loeb says. If it's natural, we'll know. If it's not, we won't get another chance. As we close this part of the investigation, remember, 3i Atlas is not proven to be artificial, but it is not behaving like any known natural object either. It's manoeuvring, it's glowing blue, it's ejecting material with no tail, and it's now less than 40 days from the most important moment in its journey. We'll be here every step of the way, decoding the data, following the experts, and connecting the cosmic dots. Engagement reminder, if you want real-time updates as this unfolds, make sure you subscribe and turn on notifications. Drop a comment. Do you think 3i Atlas will fragment, maneuver again, or surprise us with something no one expects? I read everything, and we'll be featuring the best theories in our next breakdown. In the previous episodes, we explored the visual anomalies, the strange jets, the unexplained deceleration, and the blue colour shift. But in this section, we dive into philosophy, science, and secrecy. Because now the question isn't just what 3i Atlas is, it's why we're only hearing part of the story. Let's begin at the heart of astronomy: data transparency. Typically, major celestial events are followed in real time by scientists across the globe. From NASA to ESA, from the European Southern Observatory to the Las Cumbres network, observation logs are made public almost immediately. But in the case of 3i Atlas, researchers are reporting a strange silence. Several observatories, including Mauna Kea in Hawaii, Palomar Observatory in California, and La Silla Observatory in Chile, have tracked the object. Yet only low-resolution or delayed images have surfaced. According to Dr. Eliza Quinn, astrophysicist at Caltech, we're seeing time lags in public data releases that don't match standard protocol. It's unclear whether this is logistical or something else. And when telescopes go dark on an active interstellar anomaly, it raises flags. Meanwhile, amateur astronomers are stepping in. On November 10th, the Astro Channel EU live-streamed 3i Atlas from Austria using stacked exposures and real-time commentary. Their findings: the object's brightness continues to pulsate every few hours. The colour remains consistently blue. And surprisingly, the surrounding star field shows subtle distortions, possibly due to gravitational lensing or energetic emissions. We don't have confirmation of those distortions from professional telescopes yet, but the data is under review. If true, it means 3i Atlas may be warping nearby light, suggesting a stronger gravitational influence than its estimated mass would allow. This brings us to a recurring theme: the impossible is being measured, not imagined. Let's return to numbers. Acceleration anomaly. The object slowed down by an estimated 0.0037 ms2. Not much, but impossible under known physics without a propelling force. Ejection ratio. a projected loss of 10 to 20% of mass with no symmetrical outgassing pattern. Nickel-heavy composition. Unlike water-ice comets, 3I Atlas exhibits a high reflectance, metal-rich surface. Size estimate: 4.5 km diameter, based on infrared observations. Reflectivity: uneven, as if the surface itself is shifting or modulating. And most compelling, its speed drop. Slowing down while near the sun is like throwing a rock off a cliff and watching it hover. The math does not support this, unless you introduce either technology or an unknown force. As this puzzle deepens, we're also seeing a shift in tone from official institutions. At first, NASA classified 3I Atlas as a hyperbolic comet. That classification has now been quietly revised to interstellar object. No official press release, no update alert, just a quiet database change. Why does that matter? Because the term interstellar object is deliberately broad. It doesn't imply ice, or dust, or even natural origin. It simply means this didn't come from our solar system. But what else came with it? Multiple researchers have observed smaller objects trailing 3I Atlas at intermittent intervals, not debris, not a cloud, but discrete dot-like reflectors. One such event was captured by Italy's Limescope network on November 8th, when a secondary object briefly appeared in their frame, then vanished. Analysis is ongoing, but some believe these may be small satellites, ejected probes, or fragmented companions. Think about that. If 3I Atlas has company, it could mean this is a cluster object, something larger, intentionally broken into segments. That theory aligns with what Dr. Loeb discussed in his 2021 paper on fragmented interstellar craft, where alien technology could resemble multi-part probes, each performing unique tasks. And there's another layer: radio silence. So far, no confirmed signal has been received from 3I Atlas. No beacons, no pulses, no encoded transmission. But several listening stations, including SETI's Allen Telescope Array and the Breakthrough Listen Initiative at Green Bank, have now tuned in to the object's corridor. Preliminary reports from Breakthrough's database indicate a narrow band spike in the 1.42 GHz hydrogen line, the same frequency used in the WOW signal, recorded on November 9th. It lasted only 3 seconds, too short for confirmation. But it came from the EGR direction of 3I Atlas. Is it interference, random noise, or something more? The team says it's under review. Back to visuals in instigen on crossing Kanati and what lies ahead. Using Skylive's orbital visualization tools, we can now simulate the final descent of 3I Atlas. As of today, it's approaching from the direction of Leo, crossing into Cancer by late November. And on December 19th, it will pass beneath Earth's orbital plane, just 0.04 AU away. This gives Earth-based telescopes a near-perfect viewing angle. If you're an amateur astronomer, look low on the eastern horizon before dawn, use a 6 or larger telescope with a blue filter track movement manually, or use a go-to system with custom coordinates. We're calling this the December Encounter, and what it shows might change the way we see our place in the cosmos. Philosophically, 3I Atlas raises deep questions. Why do these objects always appear unexpectedly? Why are their paths so difficult to backtrack? Why do they behave in ways our models can't predict? Some theorists, including those behind the controversial zoo hypothesis, believe we are being intentionally observed. That probes like this are dispatched to star systems that reach a certain level of technological maturity, that once a civilization develops radio, telescopes, and planetary awareness, they become eligible for passive observation. In that context, 3I Atlas could be a test, not of our military, not of our tech, but of our curiosity. 17 in. Others argue that this is simply a natural anomaly, an ice-drenched fragment from another star system, outgassing in a strange way due to internal voids or radioactive decay. It's possible, but increasingly, this view is becoming harder to defend as the anomalies pile up. The absence of a tail, the jets arranged in geometric patterns, the change in speed against gravity. And now, the potential trailing fragments. If this is just a rock, it's the most extraordinary rock ever discovered. Let's recap what we now know. As of mid-November 2025, 3I Atlas entered the inner solar system in September. It reached perihelion on October 29th. Between November 6-9, it increased brightness x5 and shifted blue. Dr. Avi Loeb publicly stated it. Maneuvered, NASA has withheld. High-rise imagery from Mars. Congress is now involved, seeking transparency. Several observatories have noted non-random jets, mass loss, and possible companion. A brief radio spike was detected on Nov 9 from its direction. And December 19th will see the closest approach. The story isn't over, it's just reaching its climax. In Part 4, we'll investigate the final theories, emerging from scientists, whistleblowers, and even ex-military officials. We'll explore possible intentions. If this is a probe, we'll look at what the Mars orbiter may have already seen, and we'll prepare you, visually and scientifically, for what to expect on December 19th, when the world watches the sky. Remember, the answer may still lie in the vastness of the stars. But 3I Atlas is no longer just in space, it's part of our story now. Engagement. Reminder, this is all unfolding right now. So if you want to stay informed, subscribe and click the bell. And let us know, do you think 3I Atlas is part of a cosmic survey mission? Or just the universe showing us how little we still understand? I'll feature the top answers in the next video. After months of speculation, observation, and conflicting theories, 3I Atlas is approaching Earth. On December 19th, 2025, it will reach its closest point, and for a few critical hours, the entire world will have its eyes on a single object in space. But this isn't just the end of a journey, it may be the beginning of something we're not ready for. 19 in. Let's start with the countdown. As of right now, 3I Atlas is roughly 6.1 million kilometers away from Earth. At 150 kilometers per second, it's hurtling through the solar system. But far more slowly than it should be. Remember, it should have been flung out of the solar system by now. Instead, it's decelerating, drifting more gently than orbital models predicted. This is not normal, according to physicist Dr. Lina Morales at the European Southern Observatory. We've triple-checked the models. There is no gravitational mechanism that explains this kind of course correction without mass ejection, and the ejection patterns we see are too clean, too symmetrical. This is not cometary behaviour. And yet, the mainstream media remains silent, but science is not waiting. Right now, across 5 continents, telescopes are preparing for a synchronised observation campaign. Here's what's lined up. Goldstone Radar, California, will attempt to bounce radio waves off the surface to detect structure and rotation. Virtual Telescope Project, Italy, live streaming the object in real time. ALMA Array, Chile, looking for chemical emissions and possible energetic signals. High-rise imagery, Mars orbiter, still unreleased but internally reviewed. Galileo Project, Las Vegas, will be deploying near-infrared sensors and polarization analysis to detect reflective surface anomalies. Even amateur astronomers with 12 scopes or larger are invited to log observations. December 19th is being called Contact Night by some forums. And not without reason. Because now, the theories begin. Let's examine the 4 dominant possibilities. 1. The natural comet theory. The conservative explanation. In this view, 3I Atlas is a highly unusual but still natural object, perhaps a nickel-rich fragment of a planetesimal from another star system. Its jets, colour shift and motion are due to internal voids, thermal expansion, or unknown cometary behaviours we haven't catalogued yet. It's rare, it's weird, but it's still natural. That's what NASA maintains, though even they've admitted, the behaviour remains anomalous. 2. The fragmented asteroid theory. Backed by independent researchers, this theory suggests 3I Atlas was once part of a larger interstellar object that fragmented, either by collision or intention. What we're seeing is the core, nickel-heavy, stable, and no longer emitting the chaotic dust cloud of a larger comet. The 7 jets are remnants of ejected material venting from fractures. This may explain the object's massive surface reflectivity and its controlled mass loss, but the jets are still too symmetrical for randomness. 3. The artificial probe hypothesis. Championed cautiously by Dr. Avi Loeb, this theory posits that 3i Atlas is not natural. It may be an autonomous, non-human spacecraft, either derelict or operational, using minimal thrust for trajectory correction. Why no signal? Because it may not be broadcasting. Or it's using non-electromagnetic means of communication. Why the blue colour? Possibly reflective coating, thermal shielding, or engine exhaust outside the visible human spectrum. Why the 7 jets? Possibly part of a stabilization system or propulsion array. Loeb has stated, "We must be willing to entertain the possibility that some interstellar objects are technological relics. 3i Atlas deserves that consideration." 4. The multi-object mission theory. This is the fringe view, but gaining traction. According to this theory, 3i Atlas is not alone. It is part of a cluster, possibly a survey fleet, entering star systems that meet specific parameters. Multiple objects, multiple trajectories. Each designed to gather data or test planetary responses. The lack of tail, the odd trajectory, and the brief hydrogen line radio spike on November 9th are seen as clues. If this is true, we may not be observing it. It may be observing us. Let's now touch on the silent actors. Since mid-November, multiple insiders have leaked that the high-rise Mars orbiter has captured at least 4 high-resolution frames of 3i Atlas, each at 30 cm pixel resolution, enough to resolve surface geometry and jet symmetry. Yet none have been released to the public. NASA has only issued a single statement. Imagery is under calibration. Preliminary analysis suggests structural variance inconsistent with standard cometary profiles. That's not a denial. It's a carefully worded statement. Add to this the recent closed-door session on Capitol Hill, where representatives from the House Oversight Committee met with members of the Galileo project. The briefing included references to object behaviour not explained by classical dynamics. Something is moving, behind the scenes. Now let's zoom out and talk patterns. This isn't the first time we've seen something like this. Oumuamua, 2017, no tail, anomalous acceleration. 2i Borisov, 2019, hyperbolic but more comet-like, 2023. K12FX, a lesser-known object with a blue signature and unexplained mass loss, briefly observed by ESA Olivar. These share 3 characteristics. Interstellar origin. Trajectory anomalies timing. Each passed Earth during late November to mid-December. Why that window? Some think it's coincidence. Others suggest it's about solar geometry. When Earth is aligned behind the Sun relative to interstellar approach vectors. Or perhaps intentional observation timing, when our defences are pointed the wrong way. This leads to the final philosophical question. If 3i Atlas is a probe, sent by an intelligence older than ours, then what does it want? Perhaps nothing. Perhaps it's passive. A recorder. A quiet observer left behind millions of years ago. Or perhaps it's listening, waiting, watching to see if we notice. And if we respond, could December 19th be more than a flyby? Could it be the first time in history that humanity stares into the void and something blinks back? 2230. Let's close with what to watch for on December 19th. Does 3i Atlas suddenly change speed again? Does it eject any new material or companion objects? Does it fragment or stabilize into orbit? Does NASA release the long-awaited high-rise imagery? Do we receive any new radio signals during or after the pass? If the answer to any of those is yes, then 2025 becomes the year humanity officially enters the unknown. And this time the world is watching. This is the story of 3i Atlas, an object that moves like a probe, looks like a mystery, and behaves like nothing we've seen before. And as it draws near, silently, swiftly, and without explanation, we're left to wonder, are we the watchers or the watched? The answer still lies in the vastness of the stars. But now one of them is whispering back. YouTube engagement prompt. Mandatory. If you want to follow this story as it continues to unfold, subscribe and turn on notifications right now. I'll be covering December 19th live and decay with new images, expert reactions, and post-flyby breakdowns. Leave your comment. What do you think we'll see? Will it split apart? Will it release more objects? Or will we get our first undeniable proof that something, or someone, sent it here? I read everything, and the best comments will be featured in our follow-up video. Stay curious, stay alert. This story isn't over, it's just beginning.